allow me to share? It's grayed out currently.
Yes. Yes, I can. Make you a co-host. See if that. Do you have sharing abilities now?
Um, no, I don't. It's still grayed out.
Okay.
Presenter. Yeah, okay, beautiful. So I will share.
Well, let me officially announce you since you did give me your amazing bio.
Yeah.
Really always awkward to kind of talk about yourself. But today, welcome. My name's Amber Lowry. I'm the program director for Cyber Up. Today, we have a guest speaker, Chris Elbring. He's an application security engineer at a financial technology startup. Prior to working in application security, he worked in IT operations/security and application development. He's also volunteered with Cyber Up, the youth mentorship, and is an active member of the local OWASP chapter. So now I'll officially turn it over to you. Feel free to drop any questions in the chat box. I will monitor it for you, Chris, and we can pause, or if you want people to unmute themselves, however you want the flow to be.
Okay. That sounds good. Can you see my screen?
Yep.
Beautiful. Can I move this? Okay, it just stays on that screen. Okay. All right. Well, yeah. I'm Chris. I'm an application security engineer, and I'm here to talk about application security throughout the software development life cycle. So, let's start off and say, what is the SDLC, right? So it's a software development life cycle. It's a methodology with clearly defined processes for the development of software. So you have it broken down into steps, right? And these are all discrete. They're all like separate from one another. It's just a way to like conceptualize it. They're like different models. They have the steps broken out differently. May depend on like the programming methodology, like if it's like waterfall or agile or whatever, or they're different programming methodologies and like paradigms or whatever. And it can depend on the company, or within the company, different teams can break out their process differently. But what's important, right, is that you have a documented SDLC for your team or company. And so I have this one broken down into 5 stages. This is a common way it's broken down. Some of them can be further broken down, but the 5 stages I have are like the requirements and planning phase, the design phase, the development phase, testing, and then implementation and maintenance. So those are the phases we will be talking about. All right, so what is security's role, specifically like application security's role throughout the SDLCs? So we want to ensure that the software that we're producing is secure. So what does that mean? We want to find the vulnerabilities in the software before the bad guys do, or prevent the vulnerabilities from ever having been created, like during the design phase or something. If we can identify something that may be insecure before it's ever even written to code, right, that's going to be a lot easier for our developers to fix and cost us a lot less money. So we want to identify them as early as possible. We want to prevent them from being created in the first place. And we want to foster a security focused culture, right? We want the developers to feel empowered. We want them to know like everything that they need to know to develop secure software. So we want them to have access to all the information that they need to uh, complete their role and create like secure software. Um, and we want to make their lives easier. So we want to integrate with the processes the developers already have. We want to, we'll get into more specifics later, but like if they use a specific like pipeline or like some tool for like if they use Fastlane for like mobile development, you want to integrate all your like DAST and SAST. You want to integrate all your tooling into pipelines and stuff that they're already using. You want to make it a seamless, smooth, like easy process. You don't want to be you don't want to make the developers' lives harder because you want them to like you, basically. You want to make it you want the developers to like you, so they'll be more apt to like listen to you. So yeah, the cost of removing an application security vulnerability during the design phase ranges from 30 to 60 times less than if removed during production, right? So this is from some study by like NIST and IBM and Gartner. So like, yeah, I mean, I think that that says the whole thing. You'll hear a lot about like shift left. Unfortunately, I made my thing a circle, so it goes kind of around a circle, but a lot of times it just goes left to right, right? You want to identify and fix things as early in the process as possible because it's going to cost you a lot less money and it's going to be just easier to fix, you know? It's way easier to like write like good secure software once than like create some mess and then like try to fix it, like you know. So that's the earliest part of the SDLC, right? Their requirements and planning phase. So this is where people come together and determine what the application or new functionality, if it's an existing application, like what it needs to do, like what this functionality is supposed to do. So here we'll have the business requirements defined. So that's what's the point of the application, what business need does it serve, like what data does it take from where to like somewhere else, you know. And we'll define the users. So like who's going to use the application and how are they going to access the application? Like are they going to have some like client that's on their phone, or is it going to be like a website that they go to? Is it going to be some like application that they have to actually download? So yeah, we're gonna define the users and how they're gonna use the application. Like what data will the application have access to and use? Will it store it anywhere? And all of these are things that the stakeholders, so like probably like a product manager, like whoever else, the people that are driving the business side of things and like asking for this functionality to be developed, like however they came to that decision, you know. These are a lot of things that they'll talk about. So what about security's roles? So in the requirements and planning phase, right, for the given business requirements, right, we'll have security requirements that go along with them. So they should be, we want them clearly defined. We want them accessible. You know, these will usually be based on some standards set either by like compliance requirements or by some organization that just defines best practices like OWASP or NIST or like something like it will usually be drawn from some like well-known like tested standard. And yeah, we want it to be accessible for developers, right? We want them to be able to access this on their own, and we want to have it be clear so they can just look it up and they're like, okay, so this is the type of application or functionality that we're using. Like, what are the requirements that go along with it, you know? And then there'll be also data security requirements. So we want to have clearly defined data classification policy, which is a document and that'll list like the different types of data and the different data classification levels. So usually this will be like whatever, I don't know, like public, sensitive, confidential, like private, like you'll just have different data classification levels and like how that data then needs to be protected. So it'll ensure that like we're handling proper data of each type as it needs to be, right? So different, because different types of data, right, it might have regulatory like compliance requirements. So like PCI DSS for like you know, payment, like credit card processing type stuff if we're taking payment information, or for if we're taking health information, right, we'll have to make sure we have to be HIPAA compliant, and like those will have very specific standards to which we need to like hold our application. So right, and yeah, so like let's look at like an example. So we have this functional requirement. So user will submit payment information that can then be like changed later through some form or something, right? But we aren't even to that part yet. So like this is just a functionality. Like we're just users can submit payment information that's then saved. They can reuse it later, but then they can also like modify it, right? So what's like a security requirement? So users should only be able to see and change their own payment information, right? So it's just setting out, defining from the beginning, like things need to be created in such a way that like users are limited to see and change only like the objects that are related to like their user object, right? So it's just very like high level right now, just writing out exact like, but it's important, right, to write out and make sure that when these things are being developed, that you know, the developers know what's expected of them. So and then like data security requirement, it's like payment information should be transmitted and stored in accordance with PCI DSS requirements. And other user information we can store that's like related to the user, right? It should be considered sensitive and transmitted and stored like in accordance with like internal policy, right? So we just want to make sure that for each function, like each like functional component, right? We have clearly defined you know requirements for both like how the functionality works and if it's like handling sensitive data, like how we're going to handle that data. So some like tools that you use, like we want to have a documentation and knowledge base. So this is like I'm trying to be like vendor agnostic, so I'm just listing a bunch of stuff. So the common ones like Confluence, you have SharePoint, which is Microsoft product if you're a Microsoft shop, Bit AI, just like G Suite, just having, but making sure that you have a central repository that's searchable, indexable. Everyone knows this is where I go if I want to know what the security requirements for X are, like whatever it is that they're implementing. We want to make their job easier. All right. So the next phase, the design phase. So this will translate the requirements into a plan of like what it'll actually look like within the application, right? And so I just have a couple of random diagrams here that'll show like a lot of how this is done, right? So we have like a data flow diagram right here, and then we have just like a systems diagram of like uh just some random application, right? So uh right, we'll have systems design. So how will the application be deployed? Like what are the different pieces of it? Because it's very rare that like you're just deploying like a web application on just like a single a single sorry, it's just WebEx said something to me. Like a single like web server or something, right? So like you'll want to map out what all the infrastructure is, right? So you might have like containers. So like you'll have some Docker containers that are deployed in like a Kubernetes cluster, deployed to some cloud infrastructure that then like manages it or whatever. So we want to understand exactly like our um how our application is going to work, the different components of it, how they fit together. Here we're going to be choosing like the programming languages, the libraries, like what sort of like database or backend we're going to use if we're using something like that, and how these different pieces fit together. And then we'll have like a data flow. We'll diagram the data flow. So it's like as data is passed from like one place to somewhere else, right? Like what does that look like? Like what data is being sent from each component to each other component? Like what data is coming from the client to like the API layer to then maybe it's being sent off somewhere else and processed by a third party and then sent back to us. And then like what do we do with the data then? So we're creating like an outline, diagrams and visualizations to make it easier to conceptualize what all the pieces are and how they're going to fit together. And this is again like a lot of documentation usually on like the developer like designers like because this also includes like the UI mockups and everything and like what the different pieces will look like and like what the forms are and then like how those map to data objects and then like what happens to them, and how we are modifying and transmitting them. So what security's role in the design phase, right? So we want to make sure that the planned implementations are secure and like in line with like best practices. So for like all the systems and stuff, and like so for if we're deploying to you know Kubernetes or something, or we're deploying to like whatever, we're using some version of some web server or something. We want to make sure that we have like default configurations that are secure, right? We want to have configurations that are reusable, right? Oh, because a lot of things now you can define infrastructure and you can define configuration as code, right? You can have just like some big file that defines exactly how things will be configured through like Terraform or like any some tool, right, that configures all your infrastructure for you. Um, so you can have defaults that align with each of the different like components of a system, right? That like you want like not code that you're writing, but just like how you will deploy these things so they're in like a secure configuration, right? And we want to document all the components, so all the code that we're writing, and also all the things that we aren't writing. So we want to document all the libraries we're using, the frameworks, any other dependency on code that we didn't write. Because I mean, like 90% or something of like most web applications is not code that your developers have actually written, right? It's code from third-party libraries, third-party like dependencies. So we want to document all this, and we want to know what all the pieces are, um, so then we can choose like we want to choose like components that are maintained still. We don't want to use some library. We don't want to have our entire project dependent on some library that like hasn't been maintained in 10 years and has like a bunch of vulnerabilities in it, right? We want to choose libraries and components that are proven implementations of like security things, or that are just proven like good, well-maintained software that you know is still being like that still has commits to it within the last like year or so. We want to make sure that we're using well-maintained stuff. So right, so if we have like a functional design where it's like, hey, so we'll have a client-side form that takes in username, address, all this stuff, passes to an API layer that then writes to the database. So for us, we'll be like, so for um, so what's like a security like requirement for that design? So we'll have to verify that the access token that is supplied along with like the form that's being submitted allows that like matches that user to the database object which they're trying to write. So this is what we were talking about before. Like we want to make sure that the user should have access to write to this. Like here's where we'll be writing out like all these access controls and stuff, and making sure that like between each component and like where data flows, like if a user tries to change something within the application, right, that we're enforcing access control, right? And we'll make sure that the API endpoint, right, is enforcing like a no cache policy on response, and we're using whatever TLS 1.2. So we're having HTTPS, right, enforced between the client and the API layer. So we'll have and then, right, we'll also have like, so this is the programming language that the API is being written in, and like we're going to use the following libraries to implement like whatever, implement the HTTP server, implement whatever else, So yeah, so basically, right, we just take whatever the design is, and then each piece of the design, right, we will come up with security controls that like have to be enforced, or and also just document like all the pieces of the design like for ourselves in the future, so we know what to test. So for design, I just like thought of some tools, like some of the like charting and designing tools. So we have like Lucid Chart, and then Visio, it's Microsoft, and then like Google Drawing. I couldn't think like a lot of this stuff, right? It's just planning, writing, documentation, like probably a lot of like meetings and stuff where you're talking through things with the designers and developers as they plan out what they're going to do, and then you can like you'll like listen and like not because not every single thing, right? You have to like hyper focus on. Like there are points within an application, like wherever users like inputting something and then it's like doing something, right? Like that's where we want to focus. If it's like we don't need to worry about probably at least like, oh, whatever animation on like the home page or something, like if they're implementing some like new thing that draws it in like a pretty way or something, like so yeah, the biggest thing is just like being in the meetings, and then for things that are like critical to the security of the application, making sure that we're involved in that. All right, so then development. So this is where code's actually written and designs are implemented. Um, so yeah, right. So developers, they're pulling in the libraries that we talked about in the design phase, but then probably also more. Like they will probably pull in more libraries and like the ones that they originally just like planned and said that they're going to use, right? So majority of applications aren't written from scratch. Yeah, like 90% of modern deployed applications are made of open source components, um, and then on top of these libraries and stuff, right? They'll write their code, and then they'll push their code to central repositories, right? Some source control management system, right? So developers can work with each other. And so usually, right, developers, they'll develop on their local machine, commit, and then push to like some server somewhere where all the code is centrally located, right? And yeah, that's how the development phase usually goes from like the functional side of things, like the developer side of things. So like what's the security's role in this, right? We want to have secure coding guidelines. Again, we want to have guidelines that are available to developers. We want them to know what's expected for different implementations, right? So like anytime you're interacting with a database, like you're going to use, some whatever, some you're going to be using prepared statements, and you're going to be using this library, like in this language you'll use like this to filter it, whatever, right? So we want to make these available to developers, want them to be easy to search, and yeah, so this could include, right, having those central implementations of security mechanisms, how you escape, prepare, and filter, user input for different interpreters and stuff. So we want to enforce style and security and IDE, SEM levels. So IDE, like the that's like the environment. That's like the basically I think it's interactive development environment. I don't know. It's like VS Code or something. It's like what the developers are actually coding in. Like if you can have security stuff being enforced there with like some linter that is scanning their code as they're typing it, like that is the best. That's the best place to catch it, is like, well, the best place to catch it is before code's ever written. But once code's being written, right, if you can catch it in the developers like IDE, you can probably save yourself a lot of time and headache. So a linter is just a tool that analyzes source code for programming errors. So these could be bugs, stylistic errors, or security, like security concerns, right? So SEM, source control management, so it's like Git. So within Git, right, you have hooks. So before someone can even commit, can even like commit their code like locally, right? You can have it run some scripts and run some like linting and check the code. So before they're even allowed to commit it locally, it's checked for like glaring security issues. And then you can also have Git hooks that run on like the server, so like on GitLab or whatever, wherever, GitLab or GitHub, wherever you're like pushing your code, you can have like you can have it run like a pre-receive hook. So then like before the code's even like taken in by the server, right, you can check it, you can scan it. Like a big one is it's like for secrets, like if people have accidentally like hard coded API keys and stuff, you can have that scanned, and then before it's even written to the server, right? It's like, hey, you left an API key like hard coded in here, like we aren't going to accept this and write this to the server, because it's really hard to actually like undo Git history and stuff. So, um, yeah, so that's what Git hooks are. So then also we'll be scanning the code repository. So SAST, it's static application security testing. And we'll talk a little bit more about that on the next slide. And then SCA, so that's software composition analysis. So we'll be scanning all the libraries and scanning the dependencies for known vulnerabilities, right? So for like libraries, right, if like a CVE is found, so like a known vulnerability in these libraries, right, that'll be published to some like list or something somewhere, that then you can have probably some software that checks that list for known vulnerabilities, and then checks like the versions of the libraries versus the versions of the libraries that you have in your applications, right? Um, so we'll be tracking our dependencies and libraries, and we'll be checking them versus known vulnerabilities, and then manual source code review. So like for very, very critical pieces, you might want to be doing manual source code review. I mean, this is the most time intensive thing. And so you probably aren't gonna be able to do it for everything, but if there's like super critical functionality, you may want to bring in someone, right, that's like an expert in the language, and have them look at it, especially if it's like a language for which there isn't a whole lot of tooling or something. Like, so with like smart contracts, which are like programs that run on the blockchain, right? Like there's very little like Solidity, like code scanning and stuff. So like a lot of times you might have to bring in someone that's like an expert to actually review the code manually. But yeah, and some issues can't be caught by tooling, so like business logic issues, but a lot of that, right, we want to make sure we catch in the design phase. We want to make sure that we're, you know, because it's like a scanning tool is not going to notice like that we aren't, like a SAST tool probably isn't going to catch that we're just allowing anyone to read anything from the database, because it doesn't know that people shouldn't be allowed to do that. So that's more something that we should have caught in the design phase and make sure that we're enforcing, right, those access controls. Okay, so SAST, right? It's static application security testing. So it works on source code, right? So we'll send all our source code to this tool. It will usually continuously scan like repos as like code is committed. Like they can usually be configured to just keep pulling. So it'll like log into some service account and pull all the code over to its own server and then analyze it. So it finds vulnerabilities like earlier than some other scanning. It's not context aware. So, right, it doesn't know anything about like runtime or environment related issues, and it cannot find those issues. And I mean, it has a high number of false positives just because of the way it works, because it's not context aware and it doesn't necessarily know exactly how, right? Like, because it works kind of like taint analysis, right? So it's like you have like a source and then like a sink, and the source might be like anything that like the user can, modify or change in some way, and then a sink could be like a database or somewhere where somewhere where like input is being like interpreted by something where it could like be danger, if it's like re-rendered back into the client or something. So the way most SaaS tools work is it finds like the sources, it finds the sinks, and then it checks the code path, and then it makes sure that it's being filtered, escaped, whatever, correctly. But it won't always know exactly like how, like you just get a lot of false positives because it won't be context aware and won't know exactly how the user will be able to like influence some of these things. So it's important, right, that security teams spend time weeding out the false positives, because you do not want to send false positives to developers. Like that's like the quickest way to break their trust. So you really want to spend time, if you're working application security, making sure you aren't sending false positives to developers, because you want them to like you want them to trust you guys are on the same team. So yes, you want to weed out those false positives. So some tools, some SAST tools, you got check marks, you got Coverity by Synopsys, Veracode. These all do basically the same thing. There's like a lot of tools that all do very similar things. Again, vendor agnostic. So like um, I don't know, but these are all things that like you could probably read their docs and stuff if you're interested and see how they work. And then for SEA, OSS vulnerabilities, OSS stands for open source software. So like these are just things that scan right all those libraries and dependencies of your software. So there's Black Duck, White Source. These are just two that are well known, like industry standard. But yes, so that's that. Testing. So this is where it goes through verification to make sure it meets the original like design and like business requirements, right? So from a functional side. So you'll have manual quality assurance, you'll have automated quality assurance, right? There are a lot of different testing tools and frameworks, right? So a lot of times it'll have to pass a bunch of automated tests and then it will go to QA, like people that will then go through and test and make sure that it is, so they'll have all the design documents and all like the business requirements in front of them and they'll make sure, right, like that when you type this in here, like it's reflected here and like it works how it said it was going to work and it meets all these requirements, right? So a lot of these like the CI/CD checks, so the continuous integration and continuous deployment, right? So a lot of this is automated, right? A lot of the deployment and stuff is automated, and so it'll just be a pipeline of a bunch of scripts and code that runs whenever code is committed to a repository or something. So then your development, a lot of times you'll have like a development server, right, that will be the same as both like your staging and your like production server or production like version of the application. So then you'll be just deploying this application in multiple different environments that are all the same, they're all repeatable, right? So then you can do testing within these different environments, and you can have all your security, or you can have like a lot of security, or not even security, we're not talking about security yet, but you can just have a lot of different tests and stuff integrated directly into that. So just upon committing code and like pushing it to Git or whatever, it'll go through a bunch of checks and then make sure that it's meeting all the requirements like that. So what is security's role? So we'll have some automated scanning. So this will include DAST, which is dynamic application security testing, and IAST, I think. I don't know exactly how you say it, but which is interactive application security testing. So DAST, it will send a bunch of different payloads to the application on all the different endpoints and stuff, and see what's returned exactly and see if it's able to get the application to do something that it's not supposed to do. And this is like a black box, right? It doesn't have access to the source code. It doesn't have access to what's actually happening inside the application. And then I asked it, it's similar, but it actually instruments the binary application, right? So if it's like interpretive, right, it will probably instrument the interpreter and look through that. Or if it's a compiled binary, it will instrument the actual binary. So as the program's actually executing, right, it will be sending payloads to it. But then also it will have visibility to what's actually happening inside the application. Like it'll have access to all the memory. It'll have access to all the like instructions that are actually being executed within the application. So it has way more visibility than DAST. DAST is like black box, right? Like you don't know what's actually happening inside the application. You're just sending payloads to it and seeing what's coming out. So IAST will probably like eventually replace DAST, but it's like not as mature. It doesn't support as many, like most of the tooling doesn't support as many or it doesn't have like a whole lot of like language support and stuff, because like DAST, right, it doesn't matter what the backend's written in, right? You're just sending payloads to it and seeing what comes back on the front end. So yes. So we'll have like automated scanning tools that'll be running constantly versus like the staging environment or versus the dev environments, and seeing if it's returning anything. And then we'll also have manual dynamic testing. So this can identify issues that might be missed by automated tooling. So that could include, right, some of those business logic issues. It might include like what am I trying to say? It might include like some issues that are just like bypassing filters in ways that just like very creative like ways. Like people a lot of times will be able to come up with more creative ways. Like if you like, especially if you like really understand the system, like maybe a way to like bypass something that some automated tooling that's just sending like a bunch of payloads, but ones that it has generated, you know, some certain way, like it won't always know exactly like what the application's doing. And if you know what the application's doing on the back end, you might be able to find some way to like bypass some filter or something in a way that like a DAST tool just isn't gonna, because it's just sending basically off like a list of payloads to see if it can get back a response that basically means that like the application's vulnerable. So yeah, and we can integrate though a lot of like our tooling, right? A lot of the scanners and stuff directly into CI/CD. So when like code's committed and like it's deployed to staging or whatever, we can have that also kick off a scan on our whatever server like that's hosting our DAST tooling, right? We can have that kick off a scan, and we can have that also kick off and go through other scripts that do security checks, just like it does checks for testing purposes from like the testing framework, right? We can have a bunch of scripts that we've written because we know how our application works that check different pieces of it to make sure that those are all working as they're intended to. And we can have the fail builds, so we can, if it's trying to build and deploy to staging and it like fails one of our security checks before even being scanned, by our tools, like we just have checks that go along. We can have that fail to build and it will just like never make it, like it just won't even be deployed, so we can be failing builds at any point, like depending on what checks they pass or fail. That's a good way to prevent bad code from being sent to production because you just don't even let it get close to prod. So some things about DAST, right? So Oh wait, it doesn't work on source code. I didn't change that. I copied that. Oh no. I'm sorry. It does not work on source code. It works on a deployed application, right? It finds vulnerabilities later in the SDLC than with static analysis. It's context aware, so it can discover runtime and environment related issues. And you'll have a lower number of false positives than you will with SAST because right, it's only going to be uh, returning when it's actually getting something back from the application that makes it think it's insecure. So like yeah, you'll very rarely have false positives, but right, you're still going to want to verify everything that comes through from your tooling before you send it on to devs. Um, so some automated DAST tools, you have like Acunetics, NetSparker, Detectify, Burp Suite Enterprise. The manual DAST tools, Burp Suite Pro, uh, OWASP, Zap. These are just different, like those are both like things to proxy and mess with like traffic between a client and a server, which is where a lot of your testing is going to take place. Like this is all for like web application testing. So for like other stuff, right? Like for compiled like binaries and like applications and stuff like that, right? A lot of times you'll be running fuzzers and stuff. So, I mean, but most of that, right? Like you'll be having a framework, but a lot of that requires more writing of the tooling yourself or just like, writing a bunch of code because you're going to have to like you'll have like some framework, right? But you'll have to give it parameters and tell it like what inputs to fuzz with what different inputs and outputs and stuff. And like, I mean, that too, like a lot of dynamic testing too, right, will require some scripting on your end. So, right, like we have a bunch of scripts we've written in Python and stuff that like check for different things whenever an application is deployed, or we use to check applications, right? Um, All right, so then implementation and maintenance, right? So now the application's monitored, or now the application's deployed, and we got to monitor it. We got to make sure it's doing all right. So, right, we want to be logging anything that's important. So that will have to have been done in the development cycle, right? But we want to make sure that these logs are being ingested somewhere and that there's eyes on them. We want to be monitoring the performance of the underlying systems and stuff. So we want to be monitoring like database health and like server load and like reads and writes on the server and like memory usage and CPU usage, all this stuff, right? We want to be monitoring and like piping in somewhere where it's all visible, like a single pane of glass, right? And also, we want to be taking in user reported issues because, like, a lot of times, like your users will find things that you missed in QA or even in security, right? So, implementation and maintenance, like, what's security's role? So, we want to make sure we have eyes on the security related logging. So, a lot of times, there'll be a different team. A lot of times, like the blue team, right, will be looking at the actual logs and checking to make sure events are being monitored, right? And that we have alerting and stuff for like if there is like some attack versus our application, right? We want to have like runtime protection if possible. This also isn't like a super like mature software, I don't think, but like there's stuff like Versec and stuff which will instrument the application at runtime and log and prevent suspected attacks against the application. So it hooks into the application, right, and it monitors and it makes sure that it's only taking code paths that are like it's supposed to be taking, and that it's only doing what the application is supposed to be doing. So we can have third-party hire testing. So this could be like from full-on penetration testing to just like a security audit of like just the application. So this is where you hire some other firm, so some third-party firm to find vulnerabilities in like your production software, website, whatever. And a lot of times this will be similar to like your in-house dynamic testing, but they will find things that like your in-house people miss because it all depends on context. It all depends on like what you know and right, even different firms might find different things with different testing methodologies and stuff. So it is important to have as many eyes on this stuff as possible. And then there's what's called bug bounty. So this is where you pay end users to submit vulnerabilities. Right. So if like some user or some security researcher that you don't have any business relationship with finds a vulnerability in your website or software or whatever, right, they can send it to you and you send them money basically as payment for having done this work for you. And that's a good way to find vulnerabilities that have slipped through the cracks. And right, we want to have continued scanning, right? We want to be scanning staging sites. We want to be scanning libraries, because there might be an advisory put out that some vulnerability was just found in library X, and then that means that we need to go update library X in all of our applications that use it, so we want to have continued scanning and continue to have eyes on that sort of stuff. And we want to review the process. We want to see how well we're integrating with the dev team, and we want to try to like improve that, so we want to be open to like criticism from the devs, or just like not necessarily criticism, but just like advice or feedback basically. And yes, and then some general tips, right? So the shift left, right, I talked about it. It's like we want to find vulnerabilities and issues as early within the SDLC as possible because it's way cheaper, it's way easier to fix them if we can get to them before code's ever even written. Training is important, right? We want our developers to be trained. We want to have foster this like security minded like environment, right? Like a culture of security, right? So we can have outside trainings, like a lot of times when you're paying for like the software and stuff, they'll let you they'll also let you send some devs to some trainings and stuff. And then there are a bunch of different organizations that do trainings too. But then also it's cool to have like your security team can put on like where I work, right? Members of the application security team put on trainings at least every quarter. Like every member of the application security team will put on a talk like this, but for the developers internally about something that's pertinent to security. Um, and right, we want to clear requirements, processes, procedures. So we want to make it easier for like product owners, project managers, developers, whoever to know what is expected of them at every step of the process. So this is our secure coding guidelines, like our design requirements, like the standards and regulatory requirements to which we're sorry, my dog's chewing the bone. To which we're being held, the standards to which we're being held. And we want to make developers' lives easier, not harder, right? We want to try to make our security stuff integrate seamlessly into their process, right? We want to integrate with tools they already use. We want to integrate with the processes that they already have, and we want to like take their input and see if there are like easier ways for us to implement like security checks along the way, because we don't want to be the bad guys. We want to be part of the team, because like we're right, we're there to help them, right? The security exists to serve business goals, right? Not the other way around, right? If we wanted to create a perfectly secure system, we would just have a computer that was like turned off. That's like perfectly secure, but it doesn't really do anything. So like business goals do come first. Security is very important, right? But we do have to make sure that we aren't we realize the point of security, right? It's so that we can continue to like meet the business goals and stuff. And so yeah, also maintain that trust of developers. Like do your very best to not send false positives to developers. You want to verify, and make sure that we are only sending them valid vulnerabilities, because we want them to trust us, because if they don't trust us, right, it's going to be very hard to get them to do what we want, because to some extent, right, we just are probably going to be making their lives a little harder than if they were just allowed to do everything they wanted all the time without ever having to answer to security. So yes, that is everything.
All right, so in the chat, we did have a couple people ask if you are able to share your slides.
Yes, I can. If where's the chat?
You can just email it to me, and then I can send it off to the attendee list if you feel like that's easier.
Yeah, I can do that. That works.
Yeah, make it easy. Okay, so anyone who's listening, feel free to either unmute yourself, drop your questions in the chat. I do have a couple of questions to get us started while you guys are thinking or typing out your questions. But I know you kept talking about the SDLC phases. Do you guys use Scrum at all while you're going through all of this? Or do you have a different kind of?
I honestly like not I don't think so. No, we are agile, but I don't think we really follow Scrum. I don't know, honestly, at my current job, and it's like very team dependent.
Yeah.
So
You were kind of just explaining it, how you want to catch these issues early, and it just reminded me of Scrum, of the quick, small adjustments before
yes.
you're at, and you're like, I am way off.
Yes. No, so I mean I do think, right, that is that it is, but it's just like not named Scrum. We don't have people that are like Scrum masters and stuff. But yeah, it's definitely in line with like a Scrum sort of
Similar.
agile methodology. Yes.
Okay. All right. Let's see. We had someone drop something in the chat. Blah, blah. When do you think the ideal time for scheduling a manual penetration test during SDLC? You mentioned early is better from a cost perspective. That also means that the pen test may not catch some issues when the software is not fully developed.
Yeah, so that's actually a very good question, and I think that will depend on business requirements and stuff. So you usually do want to be running like a full pen test, I think, versus the completely developed software. So like you would like to have caught most of the stuff before before you before you ever get to that point, right? Like a lot of your automated tooling and stuff. So I mean, I think that that is something that you probably will, because of the cost of like an external pen test, right? You do probably want to be hitting like right before you're to deploy, like for some like major release. And a lot of times, right, these external pen tests will really come in line with some like regulatory requirements or on some schedule just to show like, hey, we've had a pen test in the last 6 months or whatever. So a lot of times that will also be driven by factors that are kind of like above the head or like above the application security team. Like we'll be told like, oh, you need to have like a manual pen, like a third party pen test within this time frame. So yeah, it really depends on business requirements, but
Yeah.
yes.
So then the next question, can you recommend any source coding guidelines that we can access freely, especially for financially oriented applications?
Yeah, so for secure coding guidelines, right? OWASP has a whole lot of stuff. So there's what's called the ASVS, which is the Application Security Verification Standard. So that is a good that's definitely a good place to start. So if you just look up like OWASP ASVS, it will go through, and there it has like the different levels, right? It'll have different, I forget what they're called, but right, like you can have like a level 1, a level 2, like a level 3 application. And so like for a financial application, right, that will be like level 3, I believe. So yeah, that's like the most critical application. So stuff that performs high value transactions and stuff like that. So I would start with the ASVS and go from there. Because that'll also reference other standards and stuff. But yeah.
Okay. And then what kind of training or certifications are required to work with SDLC or in this kind of field?
What sort of so I mean a lot of it's not as standardized, so I would look into but some ones that I think are good are OSCP, which is the Offensive Security Certified Professional. It's by Offensive Security, and then OSWE, which is Offensive Security Web Expert. Those are some good ones. Yeah, application security kind of lags behind, I think, network security and stuff like that as far as the certifications offered, because it's a very wide like breadth of like stuff you might need to know. But so I think any sort of like application development experience or certifications having to do with application development might be useful as well. But yeah, like there aren't like a bunch of like vendor certs and stuff that are super applicable. So
And then what kind of either personality attributes or I guess interests of study would you suggest someone who might be interested in working in this kind of field? Like, do they need to
so
be detail oriented or,
So yeah, I mean, I think to work in application security, right? Like be like having a passion, like finding it fun, finding it interesting, liking problem solving. I play a lot of what are called CTFs, which are capture the flags, which are hacking competitions, right? And I think that that is a great way to learn about application security and see if it's something that you actually like, right? Because it's this problem solving, right? Stuff like that. So I think CTFs are definitely like something to look into. It's also a lot of fun. I'm playing in one right now. I'm playing in Hack the Box, Cyber Apocalypse. It's going on during the week, which kind of sucks because after work, and then after work I just like go do more hacking. But such is life, I guess. But it's fun, right? And I enjoy it. And I think another thing is right, other personality attributes and stuff that like you might want to consider like developing, right, is like really like being like an active listener, because like working with developers and stuff, you want to be able to um figure out like what their actual goal is, because they might be like saying something like, oh, this is what we're trying to do, but you want to get to the base of things quickly. You want to also like you want to like not you want to like maintain good relationships with these people, and you want to like be on their side, you know. So like it does take some I don't know, just like being personable and stuff like that, and not because you want like the developers to like you. So
Yeah, I'm noticing that's the common theme. Don't
yes,
make the developers angry.
yes, exactly. Because I mean that's the thing. It's like you are kind of making their life a little bit harder. So you want to be as like flexible as possible to make their lives easier.
Yeah, empathetic. All right, do we have any other
Yes.
questions? I know it is almost 11 o'clock. Any other questions before we wrap up this session? People time. I'm working on my pregnant pause to give people enough time to type. They're too shy to unmute. All right, so yes, I will send out the slides after this meeting to everyone who attended. Thank you so much for joining us today. We definitely learned a lot, especially like I said, don't make those developers angry. It's not only do you need to know the skills, but the person skills are also extremely important to play nice in the sandbox. So,
Yes.
all right, well, thank you everyone for joining us. And once again, thank you, Chris, for hosting.
Yes. Thank you for the opportunity. I appreciate it.
Yeah, thank you. Bye.